Hello guys, hope you are doing well. This is me, Mubin, and your physics teacher. So we are talking about momentum. This one another topic, collision. What is collision? The striking of two bodies with each other is called collision, isn't it? Okay. There are two types of collision. One is elastic collision, and the other is inelastic collision. Okay. If two bodies that are going to collide are rigid bodies are rigid. If they are rigid, so their kinetic energy would be conserved. Their kinetic energy would not be lost in the form of sound, heat, etc. So kinetic energy of them would be conserved. Okay, this is called elastic collision. Yes, momentum is also conserved in both of the cases. So in inelastic collision, suppose that both bodies are not rigid. If they are coming towards each other, they just strike each other and just stop. And just stop. So their kinetic energy is now zero. It is called inelastic collision. A collision in which kinetic energy is not conserved is called inelastic collision. Inelastic collision. Okay. How is it possible? Let me explain you in other words as well. So let's see this. Here are two bodies. Suppose that it is M1, it is M2, they are coming towards each other. Okay. If they are coming towards each other with the same velocity, I am saying that M1 is equal to M2 and V1 is equal to V2. And after striking, they bounce back with the same velocities. Okay. So, what was the initial momentum? If we take this velocity positive because it is in the x-axis and this velocity is negative, we can see that m1 plus minus m2v, isn't it? So the answer is 0 because m and v are equal. Now after collision, let's get back into this. After collision, I am saying that M2 has velocity positive and M1 has velocity negative. So what is the difference? Both are equal. The answer is still 0. So the momentum is conserved. In this case, the momentum is conserved. But talking about kinetic energy, what was the kinetic energy initial? It was half mv1 square plus half mv2 square. Because we ignore the values of the direction in the kinetic energy as it is scalar, so the total answer would be mv square, isn't it? Half plus half, 1. M1 and M2 are equal, so we consider it M. And V1 and V2 are equal, so we consider it V square. What is the final kinetic energy? Final. The final kinetic energy would be 1 upon 2 m1 v1 square plus 1 upon 2 m2 v2 square. Why? Because the velocity, we ignore the direction of the velocity in kinetic energy. So still the energy is equal to mv square. Hence, kinetic energy is conserved and momentum is also conserved. But but the thing is, if we talk about another case, suppose that these bodies were not rigid. These bodies were not rigid. They are coming towards each other, They just smashed each other and stopped. V zero. First of all, if the masses are equal and the velocities are equal, the initial velocity was, the initial momentum was zero. And hence the final velocity is zero, so final momentum is also zero. Momentum is conserved in this case. But if we talk about the energies, what was the initial energy? It was mv square. What is the final energy? It is zero. So the kinetic energy is not conserved. It is called inelastic collision. Inelastic collision. Okay. So how would we come to know whether the collision is elastic or inelastic? We can easily determine by relative speed of approach and relative speed of separation. Okay, let me elaborate it to you guys. So, what is the formula of kinetic energy? 1 upon 2 mv square. Here it is not the velocity, it is speed. Here we only ignore the direction of the velocity. Okay. Yes. Consider this. Consider this. Suppose that a body was coming with a velocity m1 and velocity v1, and the body 2 was coming with a velocity v2 and m2. With respect to this body, what would be the velocity of this? Its velocity would be v1 plus v2, isn't it? Okay, its velocity would be v1 plus v2. Hence, if these bodies are moving in opposite direction, this is called relative speed of approach. This is called relative speed of separation. Okay, so if this is velocity v1 and this is velocity v2, what would be the velocity of this according to this body? It would be v1 plus v, because they both are moving away from each other. If you still didn't understand it, let me give you another example as well. Consider this. Have you seen in the highway, if you are moving 2 meter per second velocity and other body is coming towards you with a 4 meter per second velocity, you will find yourself at rest. And this person coming towards you with 6 meter per second. Isn't it? Why? Because in 1 second, you will cover 2 meter distance and this will cover 6 meter sorry, 4 meter distance. So what would be the total distance? It would be 6 meter in 1 second. It was a total velocity. Okay. If the bodies are moving in the same direction, what? In the same direction, the velocities would be separated. Okay. If bodies are moving with same velocity, same direction, subtract their velocities, negative velocities. Okay, and if bodies are moving moving opposite, just add them, just add them. Now, what is the mean of reading this relative speed of approach and relative speed of separation? There's a major role in this. Okay, let me give you some explanation into this. Consider this. In elastic collision, Consider, consider half mv square plus half mv square. If the masses are equal and velocities are equal, so it would be equivalent to half m v2 v1 f square plus half m v uh, 1 f square. If they are equal, if they are equal, simple we can say that v total m v total square is equal to m v total square. Cancelling it, so v total of this side would be equal to v total of this side. Okay, it means that the relative speeds initially and the relative speeds finally are equal in elastic collision. And the relative speed, okay, let me give you some example. Consider this. This body is approaching with 6 meter per second. This body is approaching with 9 meter per second. What is the total speed? It would be 9 plus 6, that is equal to 15. Now, these both bodies are moving in the same direction, with this moving with 21 meter per second and this moving with 6 meter per second. What would be the relative velocity of this? It would be 21 minus 6, that is 15. So if the relative velocities are equal, we can say that the momentum is conserved. Okay. If the relative speeds are not equal, the momentum is not conserved. Let me give some other examples as well. The question for you guys, consider this. There are two balls. One is moving with u1, the other is moving with u2. They collide with each other. This one is moving with v2. This one is moving with, oh sorry, this one is moving with v1. This one is moving with v2. I am saying that this collision is elastic. This collision is elastic. So, what would be the velocities equation? If this is elastic, the relative speed of approach would be equal to relative speed of separation. What would be the relative speed of approach? It would be u1 plus u2. Okay, because they are coming towards each other. They are in the same direction. We can say that v2 minus v1. This is the correct equation. Okay.